Good day everyone, we are Group 4 and we are here to present Problem 315 in our book titled Introduction to Management Science, a Modeling and Case Studies Approach. Our group is composed of 5 members, namely Victoria Casanova, Kalkin Jorge, Bryan Paraiso, Jaime, and yours truly, Ina Penaflor. Our presentation outline is as follows. First, I'm going to present the problem, and then second would be the questions, which would be subsequently followed by the answers. So with that, let's begin. Alright, so starting off with the overview of problem 3.15. Computer Center for Buckley College needs to schedule the staffing of the center, which requires them to hire additional consultants. Additionally, there are 2 types of consultants, which are full-time and part-time consultants. To further discuss the specifications of each type, presented below are the consultant details. So for the full-time consultants, they are to have an 8-hour shift with a salary of $17.50 per hour. There are 3 shifts to be covered by the full-time consultants, which are namely the morning, afternoon, and evening shifts. Whereas the part-time consultants, on the other hand, have a 4-hour shift with a salary of $15 per hour. There are 4 shifts to be covered by part-time consultants, which are the 8 to 12 shift, 12 to 4 shift, 4 to 8 shift, and the 8 to 12 shift. Now moving forward to the additional information of problem 3.15, there is a required minimum number of consultants per shift, which are 6, 8, 12, and 6 respectively. And for every part-timer, there should be at least 2 full-time consultants. To understand the problem better, we also prepared a schedule table to identify which type of consultants would be taking the shift. Lastly, our main objective is to be able to distribute the full-time consultants and part-time consultants into the required minimum number of consultants per shift while minimizing costs. So that is it for the overview of the problem. Kalkin would now take over to discuss the first question of the problem.
Hello. Now, for question A, which category of linear programming problem does this problem fit, and why? So, the category of linear programming this problem falls under is cost-benefit trade-off, specifically personal scheduling. Cost-benefit trade-off problems involve prescribing a benefit that must be achieved by the activities under considerations. The main difference between cost-benefit trade-off from resource allocation is that there are certain conditions that must be taken into account to achieve the benefits. These benefits must be accomplished with minimum cost, and there is a minimum acceptable level for each benefit. The problem specifically falls under personal scheduling. Personal scheduling involves a company providing a service wherein the objective is to properly schedule its employees with respective shifts while minimizing costs. Thank you. Alright, so in the problem, each shift must satisfy the required number of consultants. Since cost-benefit trade-off should have its conditions it has to consider, that would be, for every part-time consultant, there must be 2 full-time consultants on duty. Once again, the goal of properly scheduling the consultants while satisfying the conditions must be at minimum cost. Another characteristic of a cost-benefit trade-off in personal scheduling. That will be it for question A, and moving on to question B will be Jaime. Thank you.
So for question B, we are tasked to formulate and solve a linear programming model to minimize the cost in hiring part-time and full-time workers for the Computer Center, Buckley College. So, with the goal of being able to distribute the full-time consultants and part-time consultants into the required minimum number of consultants per shift, while minimizing costs, we came up with this spreadsheet model. Along with the equations or formulas as seen on your screen, and to further discuss this, we would like to transfer to an Excel file where we and I would discuss how our model was solved. So just to recap, to better understand the problem, we have 2 types of workers, which are full-time consultants and part-time consultants. We have three kinds of full-time workers, which are assigned to work in the morning shift, in the afternoon shift, and in the night shift. They are named FT1, FT2, and FT3 respectively. On the other hand, we have four kinds of part-time workers that are assigned to work in the 8 a.m. to 12 noon shift, 12 noon to 4 p.m. shift, 4 p.m. to 8 p.m. shift, and 8 p.m. to 12 midnight shift. They're named PT1, PT2, PT3, and PT4 respectively. So, going to our model, we should first identify the cost per shift. So, for our full-time consultants, they're paid $17.5 per hour in which they each work 8 hours per shift. For part-time consultants, they are paid $15 per hour in which they each work for 4 hours per shift. And to compute, we just multiply the cost per hour and number of hours per consultant, giving us $140 cost per shift to every full-time worker hired and $60 cost per shift to every part-time worker hired. Now, going to the schedule table, I would be using the number 1 to represent the hours covered in the consultant shift and 0 if it's not covered. So, as mentioned a while ago, there are 3 types of full-time consultants working for 8 hours. So one is in the morning, which is from 8 to 12, and 12 to 4, and then in the afternoon, which is 12 to 4 and 4 to 8. And lastly, at night, which is 4 to 8 and 8 to 12. For the part-time consultants, we have 4 that work for 4 hours per shift. And for the remaining blank cells, I'll just input 0. Hold on.
Okay, so for the constraint of this part, it is about the number of consultants that should be hired per shift. So as mentioned in the problem, the minimum number of consultants per shift should be 6, 8, 12, and 6 respectively. And to incorporate this to our model, we should get first the sum product of the shifts row as well as the number of consultants. So this should be greater than or equal to the minimum number of consultants per shift. So let's just drag this down to copy the equation. So aside from this constraint, we also have another one, which is to have at least 2 full-time consultants to every part-time consultant. So for example, we have 3 part-timers, we need to have 6 or more full-timers. Okay, so to incorporate this to our model, we kept in mind that the full-time workers and part-time workers have different kinds of shift. And we decided to follow the 3 shifts for full-time consultants, which are morning, afternoon, and night shifts. And to get these constraints correctly, we followed the equation where full-time workers should be greater than or equal to the part-time workers. And the formula for each part-time workers is as follows. So for the morning shift, we have the summation of PT1 and PT2, or also called as the PTMS or part-time morning shift times 2, or this should be multiplied by 2. And the same goes for the 2 remaining shifts. The only thing that would change is that the PTMS in the afternoon should be PTAS or afternoon shift. And then at night naman, it should be PTNS or night shift. Then we just refer each cell for the full-time consultants to its corresponding cell in the number of consultants. And that is it for this constraint. So going to our main objective, which is to minimize the cost of hiring a number of consultants, we should get the sum product of the cost per shift and the number of consultants. So to know the most optimized solution, we just click on solver. And then our set objective would be the total cost. Then we minimize since we want to minimize our cost. So our changing variables is the number of consultants, the highlighted in yellow, and then in the constraint, we just add our 2 constraints mentioned a while ago. So this one and this one. And then the number of consultants should also be an integer. And then we click on the negative and simplex LP. Okay. So to answer our main question, we should have 4 full-time consultants in the morning, 4 in the afternoon, and 6 at night. And for the part-time consultants naman, we should have 2 for the first shift, none for the second shift, 2 for the third shift, and none again for the last shift. And the company's total cost for this is $2,200. That's it for question B. Thank you.
So for the next question, we are tasked to do an algebraic equation for this problem. So here are our representations, which are somehow discussed by V and Jaime already, but let me recap. So FT1 and FT1 to FT2 represents the full-time workers for morning, afternoon, and night shifts respectively. And PT1 to PT4 represents all the part-time workers for shifts 1 to 4 respectively as well. Then our main objective is to minimize cost in hiring the consultants, in which full-timers cost $140 and part-timers cost $160 per shift. So we just multiply these numbers to its corresponding number of consultants. This is also subject to the following. First is that the total consultants per shift should be greater than or equal to 6, 8, 12, and 6, respectively. Second is that for each part-time worker per shift, there should be at least 2 full-time workers. Third is that the number of consultants, or FT1 to FT3 and PT1 to PT4, should be integers and should be greater than or equal to 0. That is it for our report. Thank you for listening.